Okay, guys. So I'm trying to remember exactly where we finished since we started this last Monday. We've pushed the digestion material from what would have been on test 2 to test 3. We have briefly gotten through a little bit of it um, before we decided to push it off. I don't have your test 2 graded yet. I have to get 2 of you to take it before I grade it. So yeah, we'll talk about that. So for those of you that have missed it, the 2 of you, I've got to talk to y'all. The other thing is, I think the rain and stuff is going to be somewhat past this after this morning. I am planning on having the heart dissection today. So at 3:30, we're going to have each of our own hearts to talk about. Let me. Okay. Shelby, you okay?
Yeah.
Wow. Okay, we'll talk later, okay?
You got it.
You sound like your horse. Don't keep trying to talk. It's okay. Thank you. Okay, I'm trying to remember exactly. Did we talk a little bit about enzymes? It's further than I remember getting. Okay. Okay. Okay, so we got through the stomach. This slows and speeds it up. Okay. Well, here we go. We have kind of talked about this some as we talked about respiration, because to be able to do respiration, you have to have glucose in the cells to break down and make pyruvate and eventually transfer energy to ATP. But where do you get that glucose? You get it from usually some larger carbohydrate, either made up of 2 monosaccharides or potentially a huge polysaccharide. And so when we eat these kinds of things, think starches, for example, or sugars. So if you eat some bread, if you eat some candy bar, anything that's made of carbohydrates, at least in part, is going to start breakdown in the mouth. It will continue being broken down in the stomach and then finish in the small intestine. Okay. So if you were to eat a ham sandwich and chew without trying to swallow, the bread would start to disappear because it would break down. A ham, on the other hand, being a protein, mostly protein, will not start being broken down. There may also be some lipids there. Well, actually, there will sure definitely be lipids there with the cell membranes. Those can't break down in the mouth. Proteins begin in the stomach and then complete their process in the small intestine. And then lipids are digested and begin and end in the small intestine. So if I give you, this is not something I would suggest doing necessarily, but if I give you a teaspoon of olive oil to swallow, where will it break down? So olive oil is your clue. Small intestine, because oils and fats are lipids. If I give you a piece of bread to eat, where is it going to break down? And the stomach. So all 3 places for the carbohydrates, 2 places for protein, 1 place for lipids. So, and the reason I ask this question is because it's so easy to focus on where it starts, but not where it continues and ends. Does that make sense, Brittany? Okay. So if I say, what is broken down in the stomach, what are you going to tell me? You're going to tell me proteins begin there, but carbohydrates continue there. So we've got two things being broken down. And then all three are being broken in the small intestine. Okay, so you keep seeing this slide over and over. We've got mechanical digestion in the mouth, just as a review. Chemical digestion of carbohydrates start in the mouth. The esophagus is the movement of that food from mouth to stomach, and we get the peristalsis we've talked about. Chemical digestion of proteins begins, and carbohydrates continues. And then it gets transferred to the small intestine, where carbohydrates, proteins, and lipids are all broken down. Lipids just began there, but they also finish there. And on top of that, the small intestine is going to be absorbing those little things that we've broken the big things down into. So our small monomers, things like amino acids from proteins, monosaccharides from carbohydrates, glycerols and fatty acids from lipids. We've broken these down to small things like those that will then get absorbed. And they also get absorbed in the small intestine. So when you remember cutting open the small intestine of our salamander and you saw the wavy structure inside of the villi, there we have the increased surface area for absorption. And so the small intestine is for absorption, and then we're going to actually get rid of waste. Are you able to eat, digest everything that you eat? And that's a no. Yeah, it's not true. We can't. And how do we know that? Well, because some of what we eat actually comes out the other side. And that means our body was not able to use it. Now, does that mean that it has no energy in it? Absolutely not. Any bond would have energy, but it means that we might not have the enzymes to be able to break those bonds. Okay. If you eat wood, could you eat wood? You can. I mean, you could chew it up, maybe get it to the point where you can swallow it. Okay, let me ask you this. Can you eat paper? And paper's made from wood. So can you eat paper? And the answer would be yes, but can you digest paper? And the answer would be no. So would you see the paper again? But hopefully, we don't want to get it stuck in there and causing obstruction. But you could potentially pass it if it was small enough, but you would see it again. It's kind of like what we've got with the corn, which I think our corn thing has been sitting there for a week. We'll have to go check that out. Okay. So this absorption, only if you can break down, it's going to take place in the small intestine. So all chemical digestion will finish in the small intestine. And then you're going to get a mixture of things like bile, the lipases. Lipases are enzymes. When you see the ASE, that's an enzyme. Lipases are going to be enzymes that break down lipids. You also have bicarbonate. Do y'all remember the bicarbonate reason? I'm trying to remember if we've talked about that since it's been a week. Bicarbonate is a strong acid. Sorry, I said that wrong. A strong base to counteract and neutralize the acids that are coming out of your stomach into your small intestine. So we neutralize that acid so it doesn't damage the small intestine. Bile, we're going to come back to because, well, we'll go ahead and briefly mention it here. I can't remember if we've already talked about it now. The bile is produced as a way to help to take lipids, which break down, but don't do well in water because they're lipids, they don't mix with water. Bile has an emulsification effect, just like non-dish detergent, to help cut grease, to help break down. When I say breakdown, I'm not talking about chemical breakdown, but just take larger bits of things like oil and surround it in smaller little bits with a hydrophobic inside and a hydrophobic inside and a hydrophilic outside, so that it can become dissolvable in water and be moved around the body as needed. So we can break them down, but it takes a little extra effort. And then we absorb. in the small intestine with that little fuzzy looking space that increase the surface area. And look on the left, you're going to see this is one big villus. And then on that villus, there are also these little microvilli. So we've not only increased the surface area, but we've increased the surface area of the villi themselves. So just so we recap this, villi are multiple, villus is singular. So if I say villi, I'm actually talking about a lot of multiple villus, villus being one. So I think y'all probably already knew that, but I wanted to make sure. It's like someone saying, I want to read my syllabi. Well, you're talking about more than one when you say that, right? Not, you know, by the way, never say syllabize. That just, no, it's just not right. Okay. Now notice what's inside of the microvillus, the one here on the right. Those are vessels, right? Blood vessels. So this is a connection between the circulatory system and your small intestine, the side of absorption, because where do the monomers that we've broken down everything into, if we absorb it into the lining of the small intestine, it absorbs across and then into the capillaries of your circulatory system. So now it can be transported throughout the body to wherever it's needed. Whatever cells are lacking glucose will be able to hopefully absorb them from the circulatory system. Okay. Without such amount of surface area, we could not sustain human life. And it's because we require so much energy to run our bodies that without such surface area, we couldn't absorb enough, fast enough to be able to power us. So in this absorption, you're going to see things like water being absorbed, sodium, potassium, glucose, fructose are carbohydrates. You'll also get proteins, amino acids absorbed across the cells, the epithelial cells. You are familiar with epithelial cells now, into the bloodstream. Now notice that that's a fairly, carbohydrates and proteins are a fairly straightforward process straight to the bloodstream. Whereas with things that are lipid based, here's large globules of fats or oils. They get surrounded by the bile salts. So that bile helps to emulsify them. Notice that we go from a larger, mouse just disappeared. These larger yellow globules to smaller little droplets. We've got fatty acids. So there's some free fatty acids, but we ended up breaking them down into smaller amounts so that they can be absorbed not into the bloodstream, but into the lymphatic system, which we haven't really talked about the lymphatic system in here. In fact, I feel like it's a system that usually gets somewhat ignored. Probably in high school, if you talked about any of this, you might have talked more about the circulatory system to transport things through the body and less about the lymphatic system. The lymphatic system is really important because not only is it involved in detection of your foreign invaders, think about your lymph nodes and things, and memory of previous infections, but also it's involved in cleaning up water, excess water. Like think about swelling that occurs through water, maybe in the lower ankles, in different parts of the body. This actually absorbs that water, but in the process, it's also going to absorb these lipids. Now, what do? They take the lipids into the lymphatic system and then deposit it to the bloodstream. So it's one extra step. It's a little bit more complicated to be able to do the breakdown and then absorption of lipids. Hold on. Okay. So I'm not going to go over this too much because we have talked about this with respiration. Can you get energy from something other than a carbohydrate? You can. You can get them from proteins. You can get them from fats. And I'm not going to cover that again, but I think hopefully that makes sense to everybody since we talked about it in such detail before. If you've got questions, I think that would be a good place to start on Wednesday if anybody needs to kind of go over this again. Now, we talked about how you have waste. This is where your large intestine comes in. This is called the colon. So you may hear different forms of this. What happens here is the products that make it through the small intestine without being absorbed, without being broken down, will get pushed into the large intestine. Remember, the difference between the large and small intestine is the small intestine is longer but narrower, so the diameter is smaller, and the large intestine is shorter but with a larger diameter. And they have two different functions. So absorption for small intestine. Here we have some absorption, but not of new like monomers. We just get water absorption. And the whole purpose of this is to concentrate all of that waste. So the large intestine concentrates and stores feces, okay, which is just a mixture of water, bacteria, and any undigested and unabsorbed bulk food material. And a lot of times this is your fiber that you eat, okay? So your corn would make it this far. One thing we talked about with water absorption here is water absorption is made so that we can compact this more. This is going to sound maybe a little too personal, but the longer you wait to poop, the more likely it is that it's going to be harder with less water in it, because it'll be in there having that water absorbed over a longer period of time. Could lead to constipation. Not going to ask any questions about that, but I think y'all are familiar with maybe how that's probably worked. And if we don't want to talk about humans, you can talk about a dog. You take a dog on a walk and it's not been able to go out all day long. That poop is very different than if it's been able to eat more recently. I'll let y'all picture that. Now, not only do we have just waste, we also have bacteria, and this is actually very useful. The bacteria that live in our colon, in our large intestine, are able to digest some of that material and make vitamins like vitamin K and B12, and those are useful to us. And they are able to those vitamins are able to be absorbed and actually used in our bloodstreams for various cofactors and different reactions. Okay, so when you eat, it's actually causing a contraction of the colon, which is actually helping to accumulate that towards the end in the rectum. Now we have the ability to control this. Not all of our digestive system do we have abilities to control parts. We have the ability to control and hold the anus shut so that we don't just, poop all over the place. Okay, so we have some control on when we get to release it or not. Some of the problems that come with this can be constipation when you not able to excrete. This can be brought on by stress, aging, low fiber, disease, injury. The longer the feces remains in the colon, not only does the harder it get, but it increases the higher risk of things like appendicitis and colon polyps, which can potentially be cancerous, sometimes benign, but also cancerous. So I have known people who have had colonoscopies and polyps have been found and they've had to go back in and remove those polyps. Not fun. In lab, if y'all remind me, I will tell you a story. I won't tell you, it's not about me, but it's a story that I know of a situation that's related to damage to the large intestine. So if y'all remember in lab, I'll tell you. It doesn't work over online, so it has to be told in person. Okay, so now that we have an idea of how things work, now do y'all have any questions about how things work from beginning to end what you eat? Anybody online? Probably once, going twice. If not, we're going to talk about some of the things that you should ingest. Okay, thanks, Ryan. Okay, so some of the things that you should ingest or can ingest, and sometimes it's not so good. So we'll talk about fiber. So insoluble fiber, okay, think about the word insoluble. That's something that's not going to be soluble usually in water. Is going to be made up of cellulose. This contributes to the bulk of the fiber that we eat, and it improves colon and function and reduces the risk of colon cancer. So I have a question. Does anybody know where you find lots of cellulose in your food? Anybody know? Does anybody know what cellulose is? Heard of it before? Okay. So cellulose is probably most easily associated with things like cell walls. So do human cells have cell walls? Do animal cells at all have cell walls? The answer is no. So what organisms do we eat that have cell walls? It's going to be plants, right? So cellulose that we eat, the fiber that we eat, is actually going to be found in large part due to cellulose. So if you think about eating that wood that we talked about earlier, that would actually be a lot of cellulose involved in that. It's not something we can digest. That is a huge long carbohydrate that we don't have the ability to break down. And so it becomes fiber. Now, you think, why would we eat something like this that we can't get energy out of? Well, because it actually improves the process, the flow of the process through the digestive system. They tell you to eat more fiber to help with, well, pooping and all that kind of stuff, constipation. You see that not necessarily do things that we eat have to be about energy and extraction. It can be about the mechanics. In this case, that's what I would say that is. Now, there's also soluble fibers in a lot of the foods that we eat. These are different starches. Pectins, gums, these are things that are pretty natural. They may sound strange, but they're actually really natural. Pectin that you might use to make jelly from can actually be extracted straight from an apple. Okay, so it's natural products. Gums are also natural products. And these things can lower your blood cholesterol levels. So these are actually good. So what are we saying here? An apple a day keeps the doctor away. Okay, that's the summation of this slide, really. Because the apple is a plant, the apple is going to have insoluble fiber as well as pectin and gums. So do you see why fruit juice, as opposed to the apple, eating the apple whole is much better than just drinking fruit juice? Because the juice has had all of that fiber, all of those pectins extracted away from it. We've just got the liquid portion. Does that make sense? Okay. So you really want to eat complex carbohydrates. You want to have them for energy production, to break down over a long period of time. This also includes lots of fibers, vitamins, soluble and insoluble. So you want things like fresh fruits, whole grains, vegetables. You don't want not so good, the processed carbohydrates that have empty calories. White flour. White flour is fantastic, but it breaks down to glucose so fast. And for the most part, that white flour has had all the other extra stuff, like some of the fiber, some of the vitamins that would have been associated with wheat extracted from it. and we bleach it to make it white fast. Um, refined sugar is basically the same. Um, very little what is useful to our bodies there. Now, will it produce energy? Yes, but it will produce energy too fast sometimes. So if you've had a sugar rush off some candy, you're unlikely to get a sugar rush off of a nice potato, both of which contain lots of carbohydrates. But which one are you going to process faster? The sugar, because the sugar is already smaller. The sweeter the carb, the smaller the carb is. And that means the faster you'll process it, which is good. If you're a diabetic, then some diabetics really need glucose fast if their blood sugar is going low. So you give them sugar, you give them fruit juice, okay, things that they can process quickly and get that blood glucose level up. You wouldn't want to say, here, have some pasta. That's a longer, slightly longer process to break down and get their glucose levels up. But if you want to get a glucose level that's more stabilized, then complex carbs are a better way to do that, especially if you don't have diabetes. Okay, of course, corn syrup is thrown in that same thing. It's pure sucrose. Okay, lipids. Lipids are used to cell membranes, so you get lipids all the time, basically with anything that had a cell that you ate. And it's used in your body as an energy reserve, insulation and cushioning. If you have ever fallen as a baby, you landed on your little tushy, and it was probably somewhat padded with some lipid. Okay, think about all that baby fat. I kind of wonder if some of that baby fat is not just for energy to keep them alive, but also because they fall so much. You know, everything they do just involves getting hurt. And they're also closer to the ground, so that means they don't fall as far. But also lipids are for storing fat-soluble vitamins. Some vitamins don't dissolve in water, and so we're able to, have fat-soluble vitamins. And in fact, some vitamins that you eat, that you take internally from like through pills, should be taken with a fat source, maybe with a glass of milk. Otherwise, you don't have the ability to retain it, and it just passes through the body. We have a couple of essential fatty acids, and when something is essential, it means it's something that you have to make from your diet. Sorry, you have to obtain from your diet. You cannot make it in your own body. We make a lot of lipids, but we do not make linoleic, alpha linoleic acids. Okay, think about olive oils, for example, for those. By the way, does anybody know the word for oil in Spanish or any other Romance language? I know in Portuguese it's oleo, and maybe you see that oleo in the word linoleic, oleo. So it's actually what that word is actually saying. Now, still talking about lipids, there are good and bad fats. Unsaturated fats are liquids at room temperature. These are the kinds that you would need to eat. Polyunsaturated fats, such as omega-3 fatty acids, and monounsaturated fats, such as oleic acids. These actually are beneficial in some ways. Let's see, do I have a slide? No, I don't have that slide here. Oops. Make sure, I want to make sure that y'all can see. I've lost where I can see what y'all can see on the board. Let me stop the share just for a second. And I'm going to focus, I'm going to draw something, okay? So when you're dealing with saturated versus unsaturated fats, it may be difficult for you to remember which one's good and which one's bad, okay? So our slide says that unsaturated fats are better, right? Isn't it funny? I think in our minds, a lot of times we think of un as bad. And I think that's one of the things that maybe confuses me when I think about this. Okay, so what do you mean by saturated? So the word saturated means to be full of something, right? To have soaked it all in, maybe. So what is something that's unsaturated? Something that's not fully soaked in. Does that make sense? If I give you a paper towel and I tell you to mop up something that's spilled and it has some dry spots after you're finished, it's not fully saturated, right? It would be somewhat unsaturated. Does that make sense? Okay, so what does that mean in terms of fats? For example, carbon, okay? Carbon can have 4 bonds. And of course, all of these are organic molecules, right? We have all kinds of carbons. In fact, there's lots of carbons that we would have, okay? Now, something that's saturated, which is the bad fat, saturation would be this. Every bond that carbon can make is used. So here we've got carbon to carbon, carbon to carbon, carbon to carbon. And the rest of these bonds, what are they if it's saturated? Fully saturated with hydrogens. Okay, so that's a saturated fat, not good. Why? Because when you get lots of these saturated fats and we line them up together, they stack really well. And they become solids at room temperature. Okay, so what's unsaturated, the good stuff? What if, instead of getting all of your bonds either to a carbon and to hydrogen, you end up with something like this, a double bond, because that's always a possibility, to another carbon. Not doing a good job, but this is a really simple version. Is it now a straight line? Is this a straight line? It's not. And that's what unsaturated fats do. We don't get this straight line of carbons, we get a kink. Now, can this kink go further on with more carbons? Yeah, it totally can. Can you get more than one kink? Absolutely. If it's a mono unsaturated fat, there's just one double bond. If it's a polyunsaturated fats, there are all kinds of double bonds. But what does this mean? When these things stack together with other of the same molecule, they can't stack as well. Therefore, they're liquids at room temperature. Does that make sense visually? If I give you a bunch of pieces of paper that are really crisp and straight, you can stack them very nicely. But if I wad up and then unwad and give you every piece of paper, they're not going to stack as well. Okay? So you can make a really nice solid ream of paper if the paper is all nice and straight. And that would be a saturated fat. So things like butter, solid fats at room temperature that maybe you get from an animal. What would be that paper, bunches of paper that we've wadded up and then tried to stack together after we've unwadded it? It's got all those kinks throughout. It's not going to stack as well. It's going to take up more space. And these are things like your oils. Okay. Does that make sense? Kind of visually to visualize this? Okay. So here's the crazy thing. What about trans fats? Trans fats are actually artificial fats where we, sorry, let me put this back up here. Yeah. Trans fats are this, where we artificially take a hydrogen and force it to bond here instead of this double bond. And when we do that, we take away this double bond and look what happens to the molecules. it straightens out, doesn't it? Margarine was developed through this process. They took vegetable oil and they saturated a large portion of those double bonds so that it went from an oil, a liquid, to a spreadable something in a tub. And now you just really want to eat margarine now, don't you? That you just realize that's a chemical process that they did that. Now, just because something's a chemical process, don't be scared of it. But I would not eat trans fats. They are just as bad for you as saturated fats, even if they're artificial. So natural saturated fats are bad, or artificial made trans fats are just as bad. And it's because their molecular structures are basically the same. So just because something is made from vegetable oil doesn't mean that you should think of it as good. By the way, margarine, if I'm wrong, doesn't even have a flavor. They add those flavorings to give it that buttery. And I grew up on margarine. I probably have lots of it stored right here. I now just eat butter. Even though butter would be a saturated fat, at least it's a naturally produced saturated fat. And along the way, you also get more things. You don't just get, like, at least with butter, you're getting other minerals and nutrients that came in through the milk. So there's some other stuff there. But does that make sense how the saturated versus unsaturated kind of affects not only the health benefits, but also the literal look of the molecule, which affects the liquid versus solid. Now, coconut oil is one that's a little more confusing because each one of these has a different melting point. And coconut oil has a melting point that's really close to room temperature. Based on what I'm feeling in this room right now, it would be a solid. But a few degrees higher, it would go to liquid. So, and in fact, if you touch it, even your body temperature will heat it up to the point of liquid. So, and I'm not sure, again, not a chemist, especially not an organic chemist, but I think that has to do with maybe the number of bonds that are probably there, that are double bonds, I should say. Okay, now let's go back to the share screen. Oops. Oh, is it sharing again? Nope, that's not. Okay, there we go. So trans fats actually are probably worse. They have been linked to cardiovascular disease. There are larger amounts of trans fats found in people who have cardiovascular problems. So people who have less, so they've done some studies to show a majority of the people who've had heart attacks actually have higher amounts of trans fats than people of those that have not had heart attacks. So not food that you want to have. Okay, very quickly, we'll try to do some protein. I'm not sure we'll get to finish all of these slides. But proteins are, there are 8 essential ones that you cannot make yourself, that you have to get from your diet. Just like you had some essential fatty acids, we got some essential amino acids here. There are 8 that you cannot make, 8 that you have to get from your diet. And here's a problem with this. If you are a meat eater, then you can get all 8 of the essential amino acids from other proteins, from meats. Most plant foods, though, lack 1 or more of those amino acids. So that means you can't just eat like one kind of vegetable. You've got to eat a variety of vegetables to be able to cross. So if you combine different kinds of foods, you are able to get those 8 essential amino acids in combination. Now, does anybody remember what 2 major groups of plants will give you all 8 essential amino acids if you eat them both in the same day? Anybody remember? We did cover this. I know we talked about it. So they are legumes and grains, specifically grains from like true grains, which are from the grass family. So, that sounds strange to say it's the grass family, but that is exactly what it is. So let's get some examples here. So legumes, can y'all think of a legume? Ever heard of legumes? Pea, any kind of bean or pea, peanut, which are not nuts. Peanuts are actually the first part of the name is probably more accurate than the second part of the name. Think about like garbanzo beans or chickpeas. Same thing. So anything that's a true legume, and then when you make it in combination with things like corn, which is in the grass family, wheat, oats. I'm thinking rye and barley are also in that family. There are some plants that, if I'm not wrong, I will confirm this, but I'm almost certain that there's at least a few that do have all 8. And one of them, and it's neither a legume nor a grain, even though some people will call it a grain, it's not a true grain because it's not from the grass family. It's from a completely different family. Quinoa. Okay, is anybody eating quinoa? I love quinoa. It's so good. I put some in a soup yesterday because I made a vegetable soup of just random stuff I had in the refrigerator. And I was like, this probably is not going to have enough protein for me. What could I do? Oh yeah, I've got some quinoa. I just threw it in at the end, cooked it a little bit longer, and was quite happy. One thing about fiber that I want to bring up, especially since I was like eating this vegetable soup, the fiber that you get from plants is actually very filling. So it's a way to make yourself feel full without giving yourself an overly great amount of calories. I talked too much again. Okay, I will stop here. We're going to pick up with some interesting stuff next time. I have some links if you want to look ahead, but some of the questions y'all have asked, we're going to try to cover on Wednesday. I will see y'all at lab 3:30. I might, there's a chance I could be just a little bit late because I have a lab right before it, but it's at Plymouth Bluff. So I'll be driving back. I should be here, but on the off chance, just heads up. Okay, I'll see y'all later. Bye-bye.